In this video, I will be discussing the division algorithm. And we will try to see how this relates with the modulus in the next video. So the division algorithm, simply stated, is like this. Dividend equals divisor multiplied by quotient plus remainder. This is familiar material which we know from our high schools, but I will visit this with a few examples. So let us take this example, 29, and you're going to try and divide this by 4. So when you divide 29 by 4, this 29 is called the dividend, 4 is called the divisor, and you will have two kinds of answers. One of them is called the quotient, the other one is called the remainder. So what is the quotient in this case? 4 goes in 29 how many times? 4 times 7 is 28. So the quotient would be equal to 7. And what would be the remainder? 7 times 4 was 28, and you have 29 here, so the remainder would be equal to 1. So as you can see, 4 times 7 plus 1 equals 29, which is exactly what this algorithm is telling you. Divisor times quotient, so 4 times 7 plus 1, the remainder. So 28 plus 1, which is 29. So this is familiar material for us. But now I am going to try and go a little more deep into this. When you divide 29 by 4 to get the quotient 7, actually you'll be wondering, hey, 29 divided by 4 is 7.25. Why am I writing 7 over here? Because we are not talking of real numbers, we are talking of integers throughout these videos. All numbers we are discussing are integers. They can be positive, they can be negative, but you cannot have a fraction after a decimal point. It is necessarily 7.00 in this case. Zeros are to the right of the decimal point. So we are talking of integers, which means we have a quotient and a remainder in this case. So how do you get 7 and not 7.25? In the previous video, you remember we obtained the flow of a number, a positive fractional number, by removing the digits to the right of the decimal point. That's precisely what we would do here, which means we would have quotient equals the floor of 29 divided by 4. Simple. So 29 divided by 4, in your mind you might think it's 7.25. Take the floor of that and you got 7, which is this quotient. So that's how you get the quotient. So I would rewrite this as floor of dividend divided by divisor. What about the remainder? So let me, okay, alright. How would I write the remainder? Simple. You got 7 from this quotient. Multiply that by the divisor. 7 times 4 is 28. Subtract that product from this 29 and you will get the remainder 1. So you would write remainder equals quotient minus, quotient multiplied by divisor. So it is dividend minus that. Essentially it's the same as saying from this equation you've moved this to the left hand side and it became dividend minus divisor times quotient equals remainder, which is pretty much what I wrote over here. But I would rewrite this further. I would rewrite this as equal remainder equals dividend minus floor of dividend over divisor, multiply this with divisor. So I would rewrite this like this. I would this is how I would rewrite it, and I would rewrite, yeah, this is pretty much what I would do. So these are some very important facts that we need to keep in mind. This particular equation is very, very important. It's going to provide us the necessary connection between the modulus and actual division. If you remember in part 2 of the modular arithmetic lecture, I was mentioning about a fallacy, and this last equation you see here is going to help us provide the necessary disambiguation. Okay, now let's take a look at a second example. Instead of saying 29 divided by 4, I'm going to make one of these numbers negative, and we will see what's happening. So negative 29 divided by 4. Then in the third example we will have 29 divided by negative 4, and in the last example we will have both of them negative, and we will see what the quotient is and what the remainder is and how it translates to these definitions. So let me please insert the next slide, and here I will put example 2. This time it will be negative 29 divided by 4. So what will the quotient be? 7.25, negative 7.25. All right, the sign will be negative because one of the two numbers is negative and the other is not. So what will the quotient be? Floor of negative 29 divided by 4 equals, in your mind you can keep 7.25, but we are talking about integers, so I cannot write 7.25 here explicitly. But what is the floor of negative 7.25? Negative 8. Wow. Have you ever imagined that we will end up writing negative 29 over 4 as negative 8? We always thought in day-to-day real life that we will be writing it as negative 7.25, or you could even write as negative 7, negative 7. But this is the mathematically correct definition of the quotient, and this is exactly how the division algorithm operates. There are other alternative definitions, but this is one that really disambiguates the problem we had in video 2. So what is the remainder this time? Equals. Ordinarily you would have thought that quotient was equal to negative 7. So negative 7 times 4 is negative 28. You have negative 29. And so the remainder would be negative 1. This was what we had come across in the earlier video. But then we had a problem. In modular arithmetic, the modulus is the divisor, and the divisor is 4. When the divisor is 4, the remainder, the modulus, the remainder should necessarily range between 0 and 1 less than 4, which is between 0 and 3. So that was where we were having the problem. So now we will have divisor times, let me copy it from here all the way to here. So which will, this time it will be equal to negative 29 minus negative 8. Negative 8 was the quotient. The divisor was 4 times negative 8, which is equal to negative 29 plus 32, which is equal to 3. Aha! So the remainder is 3. Now do you see that this 3 is lying between 0 and 1 less than 4? So it is within the range. So this is exactly how you would calculate the remainder when one of the two numbers is negative. So in the case of the modular way of putting it, let me go back to the previous slide and I will write down the modulo notation. 29 is, let me insert a special character. We are going to need it now. I'll need to pull it from the open symbol format, and is the equivalent sign this one. So 29 is equivalent to remainder is 1 mod 4. You remember this one. This one is the modular way of saying it. And if I use this in the next example, I would get something like this. In modular notation, negative 29 would be equivalent to plus 3 modulo 4. Now this seems to make a lot more sense. If we had used our day-to-day notion of division to compute the to compute the equivalent number of negative 29 modulo 4, we would end up getting negative 1, which we had seen earlier. But now, by using this division algorithm and calculating the remainder with the help of this definition and using the notion of floor, we are able to understand exactly why this makes a lot more sense. And it also agrees with the fact that the remainder, any numbers, anything modulo 4 should be ranging between 0 and 3. Now let's take a look at the third example. This time I will have 29 divided by negative 3. So what is the quotient? The floor of 29 over negative 3. Oh, I'm sorry, negative 4 was the example, right? So once again, 29 divided by negative 4, the result will be negative. We will think it is negative 7.25 in our minds, but the floor of that would be negative 8. Notice how the quotient is the same in the previous example and the current example. In the previous example, this one was negative, that one was positive, the quotient was negative 8. In this example, this is positive, but this is negative, and the quotient is still having the same sign. It makes a lot of sense. Let's go to the remainder now. I will copy this equation from up here. Here we go. Oh, I'm sorry. Yeah, this should be removed. This time it will be equal to, the dividend was 29 minus, the divisor was negative 4 times, the quotient was negative 8. Was that right? Yes. Equals 29 minus 32 equals negative 3. Now if you notice one thing, in this case the remainder is negative. We have never seen this any time earlier. That was because the modulus is negative. So here is a situation where for the first time ever we are seeing a negative modulus. We have never seen a negative modulus in our previous videos, examples that is. Here's the first time we are seeing a negative modulus, and in this case the remainder happens to be negative. In fact, it will lie between 0 and 1 more than this negative modulus. So in modulo notation, 29 will be equivalent, oops, I'm sorry, let me go back here. And then I will copy this here all the way. -29 is equivalent to -3 modulo -4. We will look at one more example in which both of them are negative. And as you can expect, the remainder is going to show up as -3. What about the quotient? It will be positive, but what will be the value of the quotient? I think you can guess it right, but let us do the example. It's easy, it's an easy guess. So here, both are negative. -29 divided by -3. What is the quotient? The floor of -29 divided by -3. Oh, -4. I'm sorry. So -29 divided by -4, the quotient is positive. Keep in mind 7.25, floor of that would be 7. Remainder. Okay, before that, if you compare this one with the first example, look at the quotient over here. So when both dividend and divisor are positive or negative, the quotient is still the same. It's +7, which makes a lot of sense. How do we get the remainder now? By using the division algorithm. So let's copy that down from here. Which will in this case be equal to dividend is -29 minus divisor is 7. No, the divisor is -4 times 7, which is equal to -29 plus 28, which is equal to -1. So I had erroneously said, I think, that the remainder was going to be -3. No, it was not. It was going to be -1 in this case. The quotient is 7, of course. And the remainder here is negative because the modulus is of a negative sign. And it lies within the range. It's supposed to lie between 0 and -3. So -1 is within that range. So this is correct. So this is exactly how you calculate the modulus, or the remainder, that is. Let's rewrite this in modulo notation. I will copy this there, and this will be -29, and that will be -4, and this will be -1. Okay, so this is how we arrive at the modulus in case either the dividend or the divisor or both are negative, using this division algorithm. So this is where I will stop for now. Oops, this is not working. It should be -1. For some reason this is not coming through very well. Yes.